All right, let's dive into the invisible engine that powers pretty much every modern app you use, messaging systems and queues. Seriously, this is the secret sauce that makes everything feel snappy, responsive, and just work, even when things get crazy.
So, have you ever stopped to think about this? You tap a button in an app, maybe to order some food, and boom, you get a confirmation right away. But behind the curtain, a whole symphony of things has to kick off. How in the world does it all happen so smoothly without making you stare at a loading spinner forever? Well, that is the exact mystery we're going to solve today.
But to really appreciate the genius of the solution, we first have to talk about the problem. And that problem has a name: the synchronous bottleneck. It's kind of the old, clunky way of building software that just completely falls apart at today's scale.
Just picture that coffee shop for a second. The line would be out the door, right? The poor barista is totally blocked. They can't even think about the next person until your entire order is done, from payment to the final drop of milk. In the software world, that's your app completely freezing while it waits for some heavy lifting to finish in the background. It is just wildly inefficient, it feels awful for the user, and honestly, it makes the whole system super fragile.
So how do we fix our disastrously slow coffee shop? The answer is asynchronous messaging. This is the bit of magic that lets all the different parts of an application talk to each other without having to wait around. So let's meet the cast of characters that makes this whole thing possible.
Okay, first up, we have the producer. In our little coffee shop story, that's you placing your order. Or in a real app, it's the part of the code that kicks things off. The producer's job is super simple. It just fires off a message. Hey, I need a large latte. And then it immediately moves on. It doesn't wait to watch the coffee get made. It just sends the request and trusts it'll be handled.
So, where did that message go? It lands in the queue. Now, this is probably the most important piece of the puzzle. It's just like that metal ticket rail where the barista lines up all the drink orders. The queue acts as a buffer, a safe holding spot for all these messages, typically in a first-in, first-out order, until someone's ready to work on them.
Next up, we've got the consumer. This is our star barista, finally getting to work. The consumer's whole purpose in life is to go to the queue, grab the next message or ticket, and do the actual job. Make the latte, process the video, send the confirmation email, whatever it is. The key here is that the consumer does this completely on its own schedule, totally independent of the producer. And who's the ringmaster of this whole circus? That's the message broker. You can think of the broker as the coffee shop manager, or maybe a super efficient air traffic controller. It's the piece of software that actually runs the whole show. It receives messages from all the producers, puts them into the right queues, and makes sure they get delivered safely to the consumers. So when you put all this together, you get some incredible benefits. The big one is decoupling. This means your user-facing app and all your background services can be built and updated separately. It's the bedrock of modern microservices. You also get amazing reliability and traffic smoothing. Think about it. If you suddenly get a massive spike in orders, the system doesn't crash. The orders just line up nice and safe in the queue, waiting to be processed. This is exactly how sites survive things like a Black Friday rush.
Okay, so this all sounds pretty powerful, right? But you don't need to use it for absolutely everything. The real trick is knowing when it's the right tool for the job. So let's walk through a perfect real-world example.
A food delivery app is just a textbook case. When you hit that place order button, that's step one. Your phone, the producer, fires off an order message. That message immediately goes into a queue. And from there, different things can happen at the same time. One service, a consumer, grabs that message and tells the restaurant to start cooking. Meanwhile, a totally separate service can grab the same message and start finding a driver. And the amazing part? Your app felt instant the second you tap that button.
Now, if you decide your system needs messaging, you're going to run into two absolute giants in this space very quickly: RabbitMQ and Kafka. And while they both deal with messages, they are built for fundamentally different jobs.
Let's break this down. RabbitMQ is your classic message broker. It's like a super smart post office, great at routing individual tasks and making absolutely sure every single job gets done. Think of our coffee order. That's a perfect RabbitMQ job. Kafka, on the other hand, is a different beast entirely. It's a distributed event log. Think of it less like a to-do list and more like an unchangeable record of every single thing that has ever happened. It's built for insane speed and volume, allowing lots of different systems to read and reread that history for things like real-time analytics or machine learning. So the simple takeaway is RabbitMQ for individual background jobs, Kafka for massive streams of data.
Okay, so just using a queue automatically makes your system way more stable. But to make it truly bulletproof, you've got to understand a couple of more advanced ideas, starting with what kind of promise the system makes about delivering a message.
When a broker hands a message to a consumer, it can make one of two main promises. At most once is the fast and loose approach. It sends the message, but if something goes wrong, oh well, that message might be lost forever. At least once is much more common. Here, the system guarantees the message will be processed by trying again and again until it gets a confirmation. But there's a catch. The trade-off is you might accidentally process the same message twice if the confirmation gets lost, and that's a really important thing you have to plan for.
And that leads us right into some essential rules of the road. To handle those potential duplicates from at least once delivery, your consumers have to be idempotent. It's a fancy word that just means doing the same job twice has no bad side effects, like charging a credit card only one time even if you get 2 requests. You also need a dead letter queue, which is basically a penalty box for messages that keep failing, so you can inspect them later without breaking the whole system. And of course, you have to monitor your queue depth. If messages are piling up way faster than they're being processed, that's your smoke alarm telling you there's a fire. And finally, please, secure your brokers. They're the central nervous system of your application.
You know, this quote really just nails it. We spend so much time talking about caching to make things feel fast, but that's really only half the story. As systems get bigger and more complex, it's asynchronous messaging that gives them the stability and the resilience to handle the real world without collapsing. So the next time you use an app that feels magically fast and reliable, you'll know the secret isn't magic at all. It's just a really well-designed queue.